You know that feeling when you're just trying to read or think or uh, just exist peacefully,
Mm.
and there's that constant low-frequency noise all around you. The dull roar of a plane engine, maybe the drone from a highway.
Absolutely. Or that rhythmic, just infuriating hum from the office air conditioning.
Exactly. And, that struggle is real. That ambient noise, it's not just annoying.
No, it actively fatigues your brain. It
Yeah.
really does. And for decades, the only solution we had was to physically block it, with foam or silicone.
Or just turn the music up louder.
Right, which completely defeats the purpose of trying to protect your hearing in the first place.
Well, today, we're going to change that entire approach. We're doing a major deep dive into active noise cancellation. You'll often see it as just ANC. This is the breakdown you need to understand precisely how this, it's a complex technology, how it actually works, why it matters for your focus, and how you can choose the right system for your life.
And our mission today is really to move past that simple definition. We want to understand the physics behind it all, the clever engineering that makes sound just disappear. We'll trace its history, which is surprisingly deep, and then look at how different headphones, from tiny earbuds to those big over-ear cans, use this tech.
Okay, let's unpack this then. How do engineers manage to turn what is basically ambient chaos into silence using more sound?
It's all based on wave mechanics, and it's an elegant piece of problem solving. So active noise cancellation works by using microphones to record an unwanted sound, and then it generates an inverse sound wave that when it combines with the original noise, cancels it out.
Like dropping a pebble in water and then dropping another one at the exact right moment to flatten the ripple.
That's a perfect analogy. That concept, the anti-phase wave, is simple to grasp.
But the tech to actually do that in a fraction of a second, that's anything but simple. That's a real-time engineering challenge.
It absolutely is. We can break down the process into 3 core stages, but the real sophistication is in the speed. So, stage 1, the external microphone captures the unwanted noise wave.
The rumble.
The rumble, yeah.
Right.
Stage 2, a digital signal processor, a DSP, instantly analyzes that waveform. It looks at its frequency, its amplitude, and generates a mirror image of that wave. It flips it 180 degrees out of phase.
So if the original noise is a peak, the headphone makes a trough.
Precisely. And then stage 3, the headphone's own speaker, the driver, emits this new inverse wave. When the 2 waves meet, they interfere destructively, and the result for your ear is silence.
Wow.
The original energy is still there, but it's been neutralized by its opposite.
That's phenomenal. But wait, if the processor has to hear the sound, analyze it, and then generate the opposite wave, wouldn't there be a tiny measurable lag? How do they solve that latency challenge?
You've just hit on the biggest engineering hurdle in ANC, latency. Because sound travels so fast, any delay in processing means that anti-wave arrives too late.
And then what happened?
It can actually distort the sound instead of canceling it. This is why ANC is so good at canceling predictable low-frequency noises.
Like an airplane engine.
Exactly, like that constant drone. The system can almost learn and predict the next cycle of the wave.
So constant rumble is easy, but say sudden sharp noises or human voices are hard.
Extremely hard. Voices are highly complex, high frequency, and they don't repeat. So by the time the microphone captures a word, analyzes it, and generates the anti-wave, the original word is, well, it's already past your eardrum.
Which explains why even the most expensive headphones can kill a subway hum, but you'll still hear a sharp burst of laughter.
Precisely. The more advanced the algorithm, the better it gets at predicting those changes.
And this complexity explains why the tech wasn't perfected overnight. Our sources say the idea has been around for over half a century.
It has. And what's fascinating here is the first academic work and patents on this go all the way back to the 1950s. A guy named Lawrence LePage. It was initially explored for pilots, for heavy machinery operators, basically to protect hearing. It took decades of miniaturization and, processing power improvements to get this into consumer products.
Okay, so when we talk about how it's done, there isn't just one way to do ANC, right?
Yeah.
The sources break down different microphone placements, and this seems crucial for understanding why some headphones are better than others.
Absolutely. We classify ANC systems based on where that microphone is. And there are 3 main types you, as the listener, should know: feed-forward, feedback, and hybrid.
Let's start with feed-forward.
Feed-forward, ANC, places the microphone on the outside of the ear cup or earbud.
Okay.
Its advantage is speed. It captures the noise before it hits your ear, so it's great for those predictable outside noises like the engine hum we talked about.
Yeah.
It's also generally simpler and cheaper to do.
That makes sense. It gets a head start on the incoming sound. Well, what's the downside?
It doesn't know what sound actually made it into your ear. It's making a prediction without any confirmation. It can't correct for, say, wind turbulence over the mic or if you have a poor fit.
Okay, so if feedforward is the prediction system, feedback ANC must be the confirmation system.
Exactly. Feedback ANC puts the microphone inside the ear cup, near the speaker driver. So this mic listens only to what you are actually hearing.
Ah, so it's more accurate.
Way more accurate. It can constantly adjust the anti-wave to correct for any leftover noise or distortion.
But I'm guessing that internal placement creates a huge latency challenge.
It does. Since it's listening to the final product, it can sometimes struggle to react to new, sudden noises. And critically, because it's listening to its own cancellation efforts, it has to be tuned so carefully to avoid generating those high-pitched squeals, acoustic feedback.
A potential minefield of sound issues. So I'm guessing the premium models must use the best of both worlds.
And that leads us to hybrid ANC. This uses both an external feed-forward mic and an internal feedback mic.
The complete package.
It is. The feed-forward mic handles the initial cancellation, especially those low frequencies. Then the feedback mic fine-tunes the result, making sure your music sounds right. This combination gives you the widest frequency range of cancellation, and it avoids those feedback issues.
Which explains why hybrid systems are the most complex and usually the most expensive.
Right. The system's effectiveness really relies on three key variables: the number of microphones, the quality of the speaker drivers, and, of course, the sophistication of the algorithm in tying it all together.
That immediately raises a key question for anyone shopping for these. We've been talking about electronic cancellation, but if I just put in a good set of silicone ear tips, that already blocks sound. What's the real difference between ANC and that physical passive noise reduction?
That's a great and crucial distinction to make. Passive noise reduction is all about mechanical isolation. Think of it like earplugs. It's a physical barrier.
The seal.
The seal, exactly. The tight fit of the ear tips in your ear canal, or the sheer mass of the padded ear cups covering your ears.
And that physical barrier, the passive part, that must do the heavy lifting for the high-frequency sounds, which you said are hard for ANC to tackle quickly.
That's right. High-frequency noises, like a clattering dish or sharp voices, have these shorter, complicated wavelengths. The passive materials are just excellent at absorbing or deflecting them. But passive methods are generally terrible at blanking deep, low-frequency pressure waves.
The engine rumble again.
And that's where the active system steps in. Destructive interference is perfect for those long, predictable, low-frequency waves. The really important takeaway here is that the best results, the absolute maximum quiet, you get that from combining both technologies.
Synergy.
Total synergy. It's why in-ear or over-ear models with good electronics excel. They get the physical barrier and the electronic cancellation working in tandem.
And that synergy leads us right into the more advanced features that make modern headphones so versatile. You mentioned adaptive noise reduction earlier. This is where the tech gets truly intelligent.
It really does. So premium headphones now often feature adaptive or personalized ANC. Instead of just picking a low, medium, or high setting, the headphones are constantly analyzing the sound of your environment.
Using those external mics.
Yes. So if you move from, say, a quiet coffee shop to a noisy subway platform, the system will automatically adjust the cancellation intensity and frequency profile to match.
So it's maximizing comfort without you having to fiddle with any settings.
Exactly. It lets you move seamlessly through different acoustic landscapes.
And then there's the feature that totally flips the script. Transparency mode.
Yeah, sometimes called ambient mode, and it's basically the inverse of what ANC is trying to do. Instead of eliminating external sound, it deliberately uses those same microphones to capture the sounds around you and pipe them into your ears.
I find this mode indispensable. I can keep my music playing low, but still hear a train announcement or, talk to someone at checkout without ripping my headphones off.
It's so crucial for safety and convenience. You stay aware of traffic if you're outside, or you just maintain situational awareness. And some top-tier models, as you noted, are so smart they'll automatically switch between ANC and transparency depending on what you're doing. That is peak user comfort.
Okay, those features are amazing. But let's switch gears a bit. When we're shopping, we see different types of headphones. Does the physical form factor actually change how the ANC works? Here's where it gets really interesting. Because ANC isn't one size fits all.
It absolutely changes the performance profile because the form factor dictates your foundation of passive isolation. We can organize this around the three main types from the source material.
Let's start with type 1, earbuds with ANC.
Right, these are often the lightweight, classic open-fit models. They just sort of rest in your outer ear. They don't seal the ear canal.
So the main benefit is comfort.
Comfort for hours and a discreet design. They're ideal for people who just can't stand that plugged-up feeling.
But since they have almost no passive isolation, I'm guessing the processor has to work much harder.
Correct. Models like the 4-cell base engine, they have to use sophisticated systems because they can't rely on a physical seal. They prove ANC is possible without that deep seal, but their performance is usually best in only moderately noisy environments.
Okay, so moving up in, let's say, invasiveness, we have the super popular wireless in-ear headphones, or TWS.
Right, true wireless stereo. And
Yeah.
this is where passive isolation starts playing a huge role, which boosts the overall performance. These usually come with silicone tips designed to intentionally seal your ear canal. That seal enhances noise reduction before the ANC even kicks in.
Right, so the ANC can just focus on the deep rumble.
Exactly. And we see a lot of specialized tech here. Our sources mention the Huco TWS ANC plus ENC EQ16. We should probably define that other acronym ENC.
What is ENC?
That's environmental noise cancellation. It's a completely different process from ANC. ANC cancels noise for your enjoyment. ENC focuses on cleaning up the audio from your microphone so the person you're talking to doesn't hear all your background noise.
Ah, so it's for call clarity. That's a critical distinction for anyone working remotely.
It really is. And you can get high performance in this small form factor, but you have to get that perfect passive seal with the right size tip. Otherwise, the ANC will fail spectacularly.
And finally, the category that's traditionally been the champion of ANC performance. Over-ear headphones.
These are the big models. The ear cups fully surround your ear. They offer the largest space for drivers and often feature the most complex hybrid systems, like those from Sony and Bose. The benefit here is maximum comfort for long sessions, and the large physical ear cups offer just excellent passive isolation across the board.
Plus, with bigger drivers, they can reproduce that low-frequency anti-wave much more robustly.
Exactly. They're perfect if you need full immersion. We're talking about the industry standard setters here. The Sony WH-1000 XM5, the Bose Quiet Comfort Ultra, the Apple AirPods Max.
But there's a big caveat here, right? We shouldn't assume the highest price tag means it's the best fit for you personally, or even the best value.
Absolutely not. While those models set the standard, our source material reminds us that high price isn't always the best choice for your specific needs. Brands like 4-cell offer similar core ANC functionality at much more affordable prices.
So, we know how they work, what the options are. Let's talk practical application. Why should you, the listener, prioritize this technology?
The use cases are really broad, but they all come back to this idea of cognitive preservation. You need them while traveling, plane, train, bus, to just turn that fatiguing engine noise into silence. They're essential at work, especially in an open office.
It's an investment in your focus, really. If you value high-quality sound and the ability to disconnect from all that constant ambient noise, ANC is transformative.
Which raises an important question. Are ANC headphones actually worth the investment over standard ones? And the answer is a definitive yes, especially if you travel often, work in loud spaces, or you just appreciate pristine sound quality. They genuinely help disconnect you from street noise, air conditioning hum, and those productivity-killing background conversations.
But we have to give a balanced view. While the benefits are huge, let's talk about the potential drawbacks someone might experience, especially if they're new to ANC.
There are three main downsides. The first is that feeling of pressure or discomfort. Some users report feeling like their ears are a bit plugged or pressurized.
Why does that happen? Is it dangerous?
No, it's not dangerous, but it is a known psychoacoustic thing. It happens because the system is so good at eliminating that low-frequency outside pressure that your body detects the sudden absence of it and perceives it as an imbalance.
So what's the fix if a user experiences this?
Well, first, try a model with a slightly less aggressive ANC algorithm. Second, a lot of premium models have adjustable levels, so you can start lower and ramp up. And third, models with really good passive isolation need less aggressive active cancellation, which can help.
Okay, what's the second drawback? You mentioned sound signature.
Right. ANC can slightly affect how your music sounds, especially in budget models. Since the system is running that anti-wave, it can sometimes accidentally cancel out frequencies that are actually part of your music.
A thinner bass response, maybe?
That's a common one, yes. High-quality hybrid systems have mostly solved this, but it's a factor to consider at the entry level.
And the third, which is maybe the most practical one, is battery life.
Correct. The processor, the mics, the algorithm, they're all working constantly in real time, so noise-canceling headphones tend to consume significantly more battery. You should always expect a shorter battery life when ANC is fully engaged. It's just the energy trade-off for that silence.
So what does this all mean then? Ultimately, wireless headphones with ANC are a significant upgrade in comfort and function. They give you focus, they give you excellent sound quality, but just silencing all those distractions. Whether you go for compact earbuds or big over-ear models, the technology is effective. It bridges that gap between high fidelity and just practical usability in our very noisy world.
And for anyone looking to buy, here's a final thought for you to take away. When you're looking at your options, really consider the blend of passive and active isolation you need for your specific environment. The effectiveness of even small ANC earbuds depends so heavily on getting the right fit for that passive isolation, for that seal.
So start with the physical.
Always. If you have an excellent passive seal, your ANC system doesn't have to struggle as much. So your first step should always be to maximize that physical isolation. Let the electronics then focus on what they do best, which is those deep, constant frequencies. This understanding of balanced passive working with active, that's the new frontier of personal audio comfort.
Absolutely. So start exploring your options, and now you know exactly what to look for. Those adaptive modes, the difference between feed-forward feedback and hybrid systems, and that crucial combo of passive and active isolation. That knowledge is what turns a good purchase into the perfect one.